Now if you check regulation 41522 out, you'll see that we shouldn't exceed 50 volts of a potential difference between any exposed conductive parts and any extraneous conductive parts in an AC system. So in order for you to ensure that you're going to meet that touch voltage, one of the first things that we have to do is we have to take a wee measurement on the resistance values between anything that's within arm's reach of this extraneous conductive part. So we're going to assume that this socket outlet here, that's part of the ring final socket circuit, is within 2.5 meters. So we're getting 0.53 of an ohm here on that single socket outlet, and for this motor enclosure we're getting 0.21 ohms on the motor enclosure. So now we have to have a look within the distribution board. If you look there at the top, you'll see the 3-phase motor circuit. That's protected by a C6 MCB, and the ring final socket circuit is protected by a B32 MCB. Now that we've measured those resistance values and we've checked the rating, the type and rating of the overcurrent protective device at the origin of the supply, we're going to do some calculations to see whether or not we need to fit supplementary bonding between the socket circuit and the pipework, or the motor circuit and the pipework. So we're going to utilise that calculation, as I said earlier, that's in regulation 41522, because we're working on an AC system. The maximum touch voltage is 50 volts. Okay, the IA value is the 5-second operating current if there's not an RCD in front of the circuit that we're testing to. So these two circuits were circuit breakers, so we're going to use the operating current for the devices. So if you have a check in Appendix 3, if you look at the type B MCB, you'll see there for the 32 amp type B MCB, the actual operating current for that is 160 amperes. Okay, so we'll use that in a calculation, and then we'll check the type C while we're there. And you'll see that for the 6 amp type C MCB, the operating current for that is 60 amperes. So we'll throw those two values into that R max calculation where the IA symbol is. Remember, it's just an Ohm's law calculation, and you can see there on the ring with that 160 amps used in a calculation, we've got a maximum resistance of 0.31 ohms. So we measured 0.51 ohms, so we need to bond between that socket outlet and the pipework to ensure that the potential difference doesn't exceed 50 volts. All right. Whereas for the motor, we measured 0.21 ohms. You'll see there the maximum resistance value that we've got utilising that 60 amperes operating current is 0.83 ohms. So we don't have to bond at the motor. Hope that helps, guys.